In this video, we're going to look at some examples of calculations involving half-life. This video was specifically made for my Chemistry 1151 students. If you're in one of my physical science classes, if you're someone looking for how to use integrated rate laws and how to solve the exponential equation to do these types of problems, I'd encourage you to look at some of my other videos. So for those of you that are still here, in our first example, we're told that fluorine-18 is used in PET scans has a half-life of 110 minutes, and we're told that the fluorine-18 sample has an initial mass of 80 milligrams, and we want to know how much will remain after 330 minutes. Now, your textbook uses conversion factors to solve these problems, and that's a fine way to do it, but I find an easier way is to make a simple table. So that's what I'm going to do in all of these examples, and the tables I'm going to make look like what I have on the next slide. All right, so in these simple tables, I just have three columns where I have the number of half-lives, I have the amount of the sample that's left, and then I have the time elapsed. And I can usually just fill in the rows of this table to figure out what my answers are. So when I fill out these tables, I always start with 0 half-lives, right? So nothing has started to decay yet. So however much sample I started with, that's how much I'll put in the first row there. So I'm starting with 80.0 milligrams. I'm going to leave the units off just because I'm going to be lazy. And then the time elapsed is always going to be 0, right? So this first row is kind of my initial. And then I figure out, okay, after 1 half-life, I know that I'll have half of whatever amount of sample I had to begin with. So if I started with 80, after 1 half-life, I'll have half of that, and so I'm going to have 40. And after each half-life has elapsed, I have to add, if 1 half-life is 110 minutes, then after 1 half-lives, then this will be 110 minutes. All right, so then after 2 half-lives, I'm going to have half of this, so I'll be down to 20. And then I'll go up another 110 minutes. So, because in this case the half-life is 110 minutes, every time I go to another row, I'll go up another 110 minutes. So now I'm up to 220. And then after 3 half-lives, I'll take half of 20, so I'm down to 10. I go up another 110 minutes, so I have 330. And now I can stop, right? Because the problem was asking how much will remain after 330 minutes. So I've gotten to 330 minutes, and I see that I'm going to have 10 milligrams left, right? And what units we're using for the amount is going to be different. In this case, they gave us milligrams, so my answer is going to be 10.0 milligrams. All right, let's look at another example. All right, in this example, we're working with iodine 131. We're told that it has a half-life of 8 days. And I want to know how long it will take for a sample of iodine 131 to decay to 6.25% of its original value. So in the last problem, they were asking about math, and they gave us the final time, and so we just kind of went down until the time elapsed got to the time that they were talking about. In this case, they're giving us the final amount, so we're going to keep going down until we get to 6.25%. Now, in the last problem, they gave us the mass that we started with. In this problem, they didn't do that, right? But because we're working just in percentages, I know that before anything has decayed, I'll be starting at 100%. So my starting amount of sample is going to be 100%. Right? And that's how much I'll have after no half-lives have gone by and 0 time has elapsed. And so what I'm going to do is I'm just going to keep going down in my rows until I get to 6.25%, and then whatever is in that last time elapsed row, that's going to be how long it takes to get from 100% to 6.25%. So after 1 half-life, I'll have 50% left, and that'll take 8 days. After 2 half-lives, I'm down to 25%. That'll take another 8 days, so 8 plus 8 is 16. After 3 half-lives, I'm down to now 12.5%. 16 plus 8 is 24. After 4 half-lives, I'm down to 6.25%. Another 8 is going to be 32. So I've gotten to the percentage that they asked about. So this is my time. Be sure to put units on it. And so my final answer is 32 days. All right, and have one more example on the next slide. All right. So now we're told that it takes 4,800 years for a 6.0 microgram sample rate of radium-226 to decay to 0.75 micrograms. And now we want to know, what is the half-life of radium-226? So in this problem, I'm going to do the same thing. So I'm starting out with 6.0 micrograms, and that's how much I'd have after 0 half-lives. In this case, I don't know the half-life, so I'm not going to be able to fill out this time elapsed column, right? But all I want to do is go down, right? Keep going down by half until 6.0 gets down to 0.75, right? That'll tell me how many half-lives that takes, right? And those number of half-lives added up to 4,800 years. So all I have to do is, once I figure out how many half-lives it takes to get down to 0.75, I'll just take whatever number the half-lives is, divide that into 4,800, and the result will tell me how long a half-life of radium-226 is. So, right, after one half-life, I'm going to have 3 micrograms. After 2 half-lives, I'll have 1.5. So after 3, I'll have 0.75, right? And that's the mass that they gave me, right? So it took me 4,800 years to go 1, 2, 3 half-lives. So this 4,800 years represents 3 times whatever the half-life is. And so the half-life is going to be 4,800 divided by 3. And so that gets me 1,600 years for the half-life of radium-226.